Alright, we'll pick up the videos, the review videos for the final at question 4 now. And this asks us to find the average rate of change on an interval and the instantaneous rate of change at a specific point for a given function. The function is negative x cubed plus 3x squared minus x plus 3. And so for part A, we want to determine the average rate of change from x equals 0 to x equals 2 over that interval. And that average rate of change is going to be the slope of the secant line, the line that cuts through that function. And so that's going to be a y value minus the other y value over the corresponding x value, difference in x values. And so those y values are given by the value of the function at that x. We use the right endpoint of the interval as the first value, and the left endpoint as the second value. We could go the other direction, but we'd have to remember to reverse the direction of the x's. So you can determine these function values with your calculator, but I need to see a little bit of work at least that shows that you knew what you were doing, and so we want probably this formula at least, and one or two intermediate steps. So f of 2 means that wherever you see an x in this function, you put a set of parentheses. Put a set of parentheses, and then inside those parentheses, you want to substitute this value x, or this value 2, which that's what f of 2 means. So we have a 2 here, a 2 here, and a 2 here. And then we're going to subtract from that. We're going to subtract the value of the function at 0. So be sure to put parentheses around this entire evaluation. Be sure to put parentheses around that entire evaluation, and then make that evaluation separately before you sort of break it out of the parentheses, so that you're sure to assign the sign, to give it the right sign. So once again, wherever you have an x, you put a set of parentheses. Wherever you have an x, you put a set of parentheses, and inside those parentheses, then you want to substitute this value of x, which is 0. And so now, to turn to our calculations, 2 cubed is 8, but there's a negative outside of these parentheses. There's a negative that's going to apply to the cube of this value. Once you've cubed it, then you apply the negative. Once you've squared this value, then you multiply it by 3 and add. And then, of course, the negative just applies to the 2 here, negative 2. And so 2 cubed is 8. So this is negative 8. 2 squared is 4. 3 times 4 is 12. Minus 2 here, and plus 3 here. Now, over here, the value of the function at 0, 0 cubed is 0, 0 squared is 0, and 0 is 0. So all these terms here will just be 0. And what's left inside the parentheses is positive 3. Now, later in the exam, we will be evaluating the function at 0, and it's probable that the value is just going to be 0, but you always want to follow through with this evaluation, just in case, as in this case, it is not 0. So it's 3 in this case, and we're subtracting that, so we have a minus 3 down here. So 3 and negative 3 gives you 0. I have a negative 8 and a negative 2, which gives you a negative 10. And you add that to 12, and that gives you positive 2. You can add it up linearly from left to right, or you can do it the way I just did there. You know, just be very careful with your additions and subtractions to make sure that you get the right number here. But we just saw that that's going to be 2. In the denominator, the difference in x's is 2 minus 0, which is just 2. And so in the end result is 2 over 2, which of course equals 1. So that's the average rate of change of this function from x equals 0 to x equals 2. Now, the instantaneous rate of change is a lot easier. And for that, we just need the derivative. Well, and a substitution. But so we need the derivative, so we take the derivative of this function, and using the power rule, that's 3x squared and 6x. And this is just negative 1. Of course, the 3 differentiates to 0. So here's our derivative down here. Negative 3x squared plus 6x minus 1. And to find the instantaneous rate of change at x equals 2, we substitute 2 into that derivative. So again, evaluating means that wherever there's an x, we put a set of parentheses. Wherever there's an x, put a set of parentheses. Inside those parentheses, place the value of x that you're evaluating this function at, so which is 2. And so then 2 squared is 4. 4 times negative 3 is negative 12. 6 times 2 is 12, and there's a plus there, so it's a positive 12. And then we have a negative 1 at the end. Well, negative 12 and 12 is 0, and so the end result is negative 1. So the instantaneous rate of change of this function at 2 is negative 1. So you'll want to, if you have a graphing calculator, it would be helpful to graph the function and then look at it at that spot and on those intervals, and see if it matches what you get from your calculations. Okay, question 5 asks us to derive a revenue function and its marginal revenue function, and then analyze that marginal revenue and interpret those results. So we're given a price-demand equation, x equals 1200 minus 60p, and what we want to do is put p in terms of x. We want one variable to differentiate with respect to, and so we want price in terms of quantity. We want p in terms of x. So that means we have to solve for p. We have to isolate p in that equation. So what I've done here is I've added 60p to both sides and subtracted x, and so that's what you see here. Then I divide both sides of this equation by 60 to isolate the p. Now I've split this quotient into two terms by placing the 1200 over the denominator, 60. 1200 divided by 60 is 20. And the negative x over 60, and so that's this term minus x over 60. Then that is price in terms of quantity, and so to find the revenue, we multiply quantity times price, x times p, and so x times 20 minus x over 60 gives us our revenue function. Distribute the x and you have 20x. Distribute the x here and you have x squared. So we have 20x minus x squared over 60. That's our revenue function. Now, next we find the derivative to get the marginal revenue, because remember, when you hear marginal, think derivative. And so just using the power rule, this 20x differentiates to 20, and the 2 comes around front here, and so we have 2 over 60, which is the same as 1 over 30, and so our marginal revenue is 20 minus 30x. Now for part B, we're asked to determine the marginal revenue at a production level of 660 units, so that becomes a quantity. The quantity is 660, and then we interpret the results. So marginal revenue at 660 is given by R prime of 660, which is 20 minus 660 for our x over 30. 660 over 30 is 22, so this marginal revenue at 660 units is 20 minus 22, and that gives us a negative 2. So this tells us that at a production level of 660 units, revenue is decreasing at the rate of $2 per unit produced. That is what is meant by interpret the results. Then in part C, we want to know what the marginal revenue is if our production level was 540 units. And so for that, we substitute 540 into our revenue function, 20 minus x over 30. And so our x is 540. Wherever we have an x, we put parentheses. Inside those parentheses, we put this value, 540. 540 divided by 30 is 18, and so 20 minus 18 is 2, positive 2. And so that tells us revenue is increasing. So our interpretation is at a production level of 540 units, revenue is increasing at the rate of $2 per unit produced.